Okay, so with these things out of the way, we know that we can write NC n minus r. So let us now directly use the formula, the expression for this n factorial n minus r factorial times n minus r factorial. Okay, and what does it give me? N factorial divided by n minus r is r factorial times n minus r factorial, and if you look closely, it is nothing but NCR. So this is just the derivation of this simple formula. But this formula becomes useful when you have something like this: 100 C 98 or 97 say. Two very big numbers which are somewhat very close. The difference is small, but the numbers are big. So in this case, what you can do, 100C 100 minus 97. So that becomes 100C3. So one of the numbers becomes small, the one that appears below, right? And there is one more property which is even more important. It says that NCR plus NC r minus 1 equals n plus 1 CR. The restrictions to R in this case are clear. R minus 1, since the smallest number appearing here below in the lowermost line, I mean a suffix, R minus 1 has to be greater than or equal to 0, and this has to be less than or equal to n. Okay, this condition should be satisfied. Then only this makes sense, which you can write equivalently as 1 less than or equal to r, which is less than or equal to n plus 1. So you can see that because of this, since r is greater than or equal to 1, it's automatically greater than or equal to 0. So this binomial coefficient makes sense. This one also makes sense. What about this one? R has to be less than or equal to n. Okay. R has to be less than or equal to n. Okay. If R becomes n plus 1, that fear is there. That has to be taken care of. If R becomes n plus 1, then this becomes meaningless. So R cannot be equal to n plus 1. That has to be imposed separately. Okay, R cannot be equal to n plus 1. So it is coming from here. So that means R minus 1 has to be strictly less than n. So this is the condition. These are the conditions on R. Okay, so that is there. But now we have to see that this formula is true. So let us verify. Let's take the left hand side. NCR plus NCR minus 1. We directly write the formulas for these expressions. N factorial divided by n minus r factorial times r factorial plus n factorial divided by n minus r minus 1 factorial times r minus 1 factorial. While performing calculations like this, it's better to write them in detail to avoid making any mistakes. Now, unless you are very familiar with these calculations, do not skip steps. Okay. N factorial divided by n minus r factorial times r factorial plus n factorial divided by n minus r plus 1 factorial times r minus 1 factorial. Now to make it look somewhat more easy, what I will do, I will further write it like this: n minus r factorial times r times r minus 1 factorial. What I have done here, in place of r factorial, I have written r times r minus 1 factorial. That's what it is, right? Similarly, for this one, I write n minus r plus 1 times n minus r factorial times r minus 1 factorial. Okay, here this factor can be written as a product where one factor is n minus r plus 1, the other one is n minus r factorial. Now if I take, okay, now see, there are some terms that can be taken common out. N factorial divided by n minus r factorial available in both the terms of this sum times r minus 1 factorial, and we are left with 1 divided by r plus 1 upon n minus r plus 1. And this equals n factorial divided by n minus r factorial times r minus 1 factorial. R times, let me write it like this: n plus r minus 1. In the numerator, we have n minus r, or n plus 1 minus r plus r. So this equals n factorial times minus r plus r, they cancel out. So we have n plus 1 divided by, now I decide to write n plus 1 minus r along with n minus r factorial and r along with r minus 1 factorial. So now the numerator is n plus 1 factorial. Here I have n plus 1 minus r factorial multiplied by r factorial. And if you look at it, this is nothing but n plus 1 c r. So that's how we get this formula. This formula is very useful. It's used most often when we deal with problems which involve these binomial coefficients. And this formula leads to something called Pascal's triangle. Which is a very interesting thing. We will come across this when we study the binomial theorem. Now, having seen some elementary properties of these coefficients, we are now going to go to the actual problems. So the problems look like this.